Yeah, cool. We're recording. Okay. So, welcome to Intro to Cyber Reconnaissance. Really cool stuff. Uh, Not too many people here. I didn't expect that many. It is a long weekend. So, agenda today, some side notes, looking at where you are in the network, looking at network mapping, version scanning, and mapping versions to exploits, and then a little bit of practice. So opening with side notes, uh, the network gods were not with me for the past few days, so I could not get vulnerable machines for you up in a safe way. I can get them up. I just couldn't figure out a way for you to not be able to touch our other infrastructure. Um, so custom slug security challenges coming soon. So we're pivoting to the next best thing for the practice or the hands-on stuff, which will be offensive securities vuln hub collection. Essentially, they just give you OVAs or virtual machine files. So during this meeting, there is a thing I want you to install. It's only 2.4 gigs. I would suggest doing this with VirtualBox instead of VMware because I don't know VMware networking. But if you want to do that, you could just go to vulnhub.com and search up basic pen testing, and then just grab this one. Grab the mirror because the original download link is down. Just download this while we're going through the techniques. Sound good? Can I get some people thumbs up in chat so I know we're good to go? I got thumbs up in here. All right. I want to move on. So more info on the demo later. We're gonna do some hands-on stuff with the network mapping, and it'll be fun. Next up, don't break the law. So I'm not a professional attorney. I never claimed to be one, but network scanning, to my knowledge, is not illegal. But it is most likely against the policy of any institution's IT department, um, whether that's our university or your company or maybe the apartment building you live at. It's probably against their policy to network scan it. Non-internal IP ranges, so basically the open internet is a free range. You can do whatever you want there with network scanning. You won't get arrested. But if you do it internally at school or at work, you will probably get an angry email. It is very easy to detect network mapping to a degree, which we'll talk about. So consider, maybe not doing that to stay on the network. I know some IT teams will just block your access to the internet until they can have a meeting with you and say, hey, don't do this anymore. So consider the store policy, no shoes, no shoes, no shirt, no service. So don't network map on networks you don't own. At home, feel free to do this. There's no harming any systems. For our stuff, please don't do that. We have intrusion detection systems for our cyber range and stuff like that. We have honeypots on the networks that are not meant to be touched. So if you do that, we'll know, and we're gonna have to talk with you, which is not fun. So if we give you access to stuff and we say don't scan it, please don't scan it, we will know. Um, just be nice to us. Okay, moving on. So let's talk about the network basics. So first of all, you join a network, right? You go to a new coffee shop, you go to join a new network, or maybe you're at a competition like CCDC, CPTC, and you just got on the network. You want to, first of all, orient yourself if you're looking at an offensive or defensive side, basically figure out where am I, what neighborhood am I in, and who lives on my street, and, maybe are there any cops on my street that will get mad if I start knocking on doors? Um, so you want to get a lay of the land, essentially be able to figure out where you are on the network. And when we say neighborhood, what we really mean is understanding what subnet we're on. So that is the neighborhood equivalent of, the network we're on in the cyber realm in terms of speaking. So to go over really, really basic networking principles, this is an IP address. It's an internal one, 192.168.13.37. This is just a simple IP address, right? And if you didn't know, this is in IPv4 format. Um, Pretty simple. Only has 4 sections, and there's an alternative. You may have heard of it. It's called IPv6. There's a small little example. IPv6, in my opinion, was a mistake. Avoid using it. IP addresses were made to be easily, translating a computer's network location. It shouldn't be like 64 characters or whatever to say what the address of a computer is. So don't use it. We have network address translation for a reason. We're not going to run out of IPs. So I don't suggest using IPv6 ever. Um, Going more into detail about IP addresses, there are octets within the IP address notation. So we have four. Essentially, they kind of make up the entire IP. So when I say the first octet here, I'm talking about 192. When I'm talking about the fourth octet, which is usually the most important on a network or when you're working with others and trying to tell them, hey, connect to that machine, usually say the fourth octet or the last one. Because usually your neighborhood or your subnets are small, and that's the only thing that changes. So you would usually say maybe like dot 37, or maybe at most dot 13, dot 37. And when we're talking about IPv6, or sorry, IPv4, each one of these octets can be from 0 to 255 because they're only 8 bits. So this is a 4-byte address. Really cool stuff. So these are other examples of IP addresses if you've never seen them before. When you usually deal with computers, you're dealing with domains. So, google.com, you're not really going to Google's IP, you're going to google.com, and then your computer is resolving it. And, in the back end, it's using IP addresses, but usually you only see domains. So just consider this is what powers the internet and things like that. So going back to the neighborhood we're in, right? The network subnet. Essentially, a subnet is a way for us to list a range of IPs. We use something called classless interdomain routing or CEDR notation. Here's an example, 192.168.1.0/24. That is an example of a CEDR notation representing a subnet. The format of this is pretty simple. You just have the IP range and then you have the prefix length. The prefix length itself denotes how many bits of the address are used for the networking bit, so the IP bit. And then the lower the prefix, the more IPs in your range because less bits are going to that network area, which is the first part. So here are some examples. If we have 192.168.1.0/24, essentially the fourth octet can be anything between 0 and 255, which is inclusive, so it gives us a possible range of 256 IPs. If we go down to only 18 bits for the networking part, we can actually lower this to 192.168, and now we can actually control a range of the third octet, but only to from 0 to 63. And then the fourth octet is 0 to 255. So giving us 16,000 possible IPs in that range. And then we can keep going down to 16, which just gives us full control of the two last octets, which gives us about 65,000 possible IPs. Now, if I remember correctly, because we're using IPv4, which is 32 bits, we have in total about something, I think 3.4 billion IPs. Higher?
More like 4.3.
4.3? Okay. Something like that. Um, but yeah, it's a relatively small thing when you're talking about, unique IPs. And that's why we moved to IPv6 so we can have more bits for more IPs. But we solved that issue with network address translation or NAT. So people kind of didn't use IPv6, even though it's out. So I don't think we should worry about that stuff. But for now, just keep in mind this is how IPs work, and they're pretty simple. So don't get scared when you see those IP subnets. So moving on. So actually figuring out where you are in network. So whenever you join a network, usually what happens is your computer is assigned an IP address. Uh-oh, unstable network. Um, Without an IP address assigned to your computer, you're not going to be able to talk to basically any machine, because in order to communicate, on the protocols we use, you need a source IP address, which is what your computer's IP address is. And you could do this in two ways. You can statically set it, or basically explicitly say, this is my computer's IP, and that won't change over time. Or most commonly, what we see is dynamically assigned IPs. So basically, you join a network, and whatever router or gateway you joined with will assign you an IP on the domain, which is pretty simple. And that's what we mainly use. It's called DHCP or domain host something protocol. I don't remember. But essentially, it's there and it automatically assigns you an IP when you join a network. Now, finding your actual IP on a network is very simple. If you're not confident in being able to find your IP, you can, go to your settings, go down to your Wi-Fi and peek in there. Or, we're using Kali, so we can open up our terminal, type in IPA, and this will give us a nice colorful view of our current networking, and we can see that we have our IP over here, which we'll cover. So running IPA will give you a rundown on most Unix and Linux machines of what your current networking setup is. You have that first loopback stuff. You don't need to worry about that. You can see they have IPv6 here for locally looping that. That will never get used, but you may have seen 127.0.0.1. That's just ping back to your local computer. If you have multiple ports, you may see ETH0, WLAN 0, maybe WLAN P1 or things like that. But most commonly, it's something like WLAN 0 or ETH0, depending on what network interface you're connecting with. And here we can see our current local IP and our current subnet. So pretty simple. Whenever you use IPA, it'll just be next to that INET, and that is what is assigned. So pretty simple finding that. And here you can actually see your MAC address if you're ever curious. Most computers rotate it, so it doesn't matter too much, but it exists. So knowing where you are. So let's say my INET on IPA says that my IP address is 100.64.58.9/21. So my take from here is my current IP is that IP 100.64.58.9, and my subnet or prefix mask is basically /21. So 21 bits are going to the networking segment. So what this says about my network is that right now, in my current area, there's the range of devices can have IPs of 100.64 dot from 56 to 63, and then the last octet is all up for grabs. So this gives us about 2,048 IPs on my current range, which is pretty normal for, I think, most modern access points, which can support about 2,000 devices, so that's not too far off. So maybe one access point or wireless access point is supporting up to 2,000 devices here on campus. So, cool stuff. Now, as we said before, orienting yourself, we know where we are, we know our neighborhood. Let's find out who's living on my street. So we know that the IPs in our range or our current subnet can range from this address right here. So what if we just go down and start, knocking on doors and start saying, hey, are you here? Are you here? Are you home? Whatever. So we can start pinging, right? Everyone's probably used ping before. If you've used, I don't know, Windows, Mac, Linux before, you've probably always used ping to like resolve some kind of networking issue. We can just do that with all the IPs. But here you can see that I'm not hitting anything. So, you know, I'm kind of going door to door, not finding anyone inside. So this is pretty bad. So let's talk about network mapping, which is kind of like the meat of today's lesson in, reconnaissance. So when we talk about pinging, we're using something called Internet Control Message Protocol, which is basically your computer asking another computer, hey, are you there? Are you alive? Are you up? Um, the computer can choose if they want to reply or not, depending on some firewall settings. Most of the time, devices will reply. The only exceptions I've seen is if you tell your firewall not to, um, you disable host discovery or something like that, or you kind of run your own security rules and say, hey, computer, don't talk to other computers when they're asking if you're alive. Um, so sometimes you won't see them up even though they are. This allows us to debug networks pretty easily, right? You're able to check, first of all, if you're reaching computers. And if you're able to reach the computer, usually that means it's booted into its operating system. Because if it's stuck in a boot loop, if it's, I don't know, in a BIOS menu or something like that, it's not going to have an IP address unless you're talking about some kind of enterprise server, like a Dell PowerEdge that has a management console and has another smaller computer inside of it, which always will be on and have an IP. So that's a cool way of seeing if your computer is on or not. And another thing we could do is we could check for packet loss. Maybe you made some new Ethernet cables, maybe they're kind of terrible. You can check if packets are dropping pretty easily and, check your latency and things like that. So pretty basic. But since then, we've moved on from ICMP over to kind of TCP handshakes when we're using network scanning. And we'll talk about the different methods of Nmap doing that. So going into Nmap, this is essentially kind of like the golden standard of network mapping. There is also CrackMap exec, which is usually used for Windows systems, but I decided not to cover it because I thought it was going to be too complex. So we're just sticking to the good old Nmap here. So it can allow you to do various things, mainly network mapping, right? It's in the name. So network map or Nmap, basically pretty simple. Give it a target, tell it how you want it to scan the target, and then watch it go. Some capabilities on it are really cool. So first of all, it can ping networks and go through pretty much every IP on a network and see if they're up by sending ICMP. It can tell you what ports are open or closed on each machine, maybe even if they're filtered or not. You can even see what version of software is running on a machine through version scanning, which we'll cover. And it can even run custom scripts like vulnerability explorer tools and things like that. So you can find out if anything attached has a CVE or an exploit. So we're going to go level by level through these capabilities and kind of talk about how you can do this. So starting off at level 1, which is basically going to do that door-to-door, knocking, but much faster. The way we can do this is we just say, hey, Nmap, I'm going to give you this CEDAR notation, which we talked about, which is just a range of IPs. I want you to go to door and just do a ping scan. So we're not looking at any ports because that takes additional time. And we're basically just discovering which hosts are up. Here we can see that we have 14 hosts up. And as I said before, that /24 tells us that we only have 256 IP addresses we can scan. And we can see that's correct. And you can kind of see that it went down sequentially, starting from 0 down to 255. And then, pretty cool. So 14 hosts up in this network. So going up a level, we want to maybe see what's running on a certain host. So we'll pick .243. Here, we can just run nmap normally without any arguments on that direct IP range. And you can not IP range, but that one IP. You can also do this with the IP range, but it might take longer because you're doing port scanning on all those IPs. which does take a little bit. So here we can see Nmap finished scanning, and we have a rundown of what's happening. So we only scanned one IP address, and that one IP address is up. And we also scanned the first 1,000 ports from 0 to 1,000 because those are usually the most common ports we see on devices. So network map is, or Nmap is trying to basically save you time and only scan the initial most popular ports, which usually we see denoted with things like SSH, web services, RDP, things like that. So here we can see that Nmap reported that 4 ports are open. We have port 22, 80, 443, and 5900. And it even tells you what each one is. So port 22 is SSH, 80 is HTTP, 443 is HTTPS, and then 5900 is VNC. So this gives us a rundown of what's on here. So we know that there's a uh, secure shell here, so we can remotely log in. There's some kind of website running here, and we have some VNC or remote client available on there that we can connect to. So this already gives us a really good rundown. But as I said before, we only check the first 1,000 ports, and sometimes you'll find some extra hidden services on all the different ports because it can go up to about 65,000 ports. So how do we do that? Well, we can use the -p flag here with another dash to say there's no limit on the port range we want to go to. And as you could see, it did that pretty quickly. Only in 10 seconds, it scanned all the ports on this one machine. You could see, scanned 65,000 of them, they're closed. And then those 4 that we saw before are still open. This is why Nmap usually doesn't scan all those ports, is because it takes a lot longer. And, most of the time you don't find anything new, but sometimes you will. So cool way of just quickly checking everything. All right. So far, we're able to take inventory of what machines are up or online, which ports are open. This can maybe tell us what services are running. So maybe how can we go deeper? So we know SSH is running on that machine, but we still don't know what version. So that's what we want to look at next. There are some small issues. So whenever you do this, this is very loud. This is like screaming in your neighborhood, right? We keep talking about this analogy of the neighborhood saying, "Hello, are you home?" Now, to every house on the block, your neighbors can slowly start hearing you coming over and, yelling, and they might call the cops. That's the last thing you want to do that. So there does exist stealth scanning, and I'm not going to cover that because it does take a mix of different Nmap arguments, basically slowing down your progress and things like that. So it is possible. It's just you got to find the right balance between how to be less aggressive with your scams. And you could really easily do that if you do nmap dash dash help, or I think we could just do nmap dash help. You can see we get all these help options. And in here, you will probably find things like stealth scanning. If I can maybe, let's see if I can find it. Scan techniques. So yeah, there's many different ways of doing it. But some are less obvious than others. But pick which one you want to do and just stick to it.
Is Nmap like included within the operating system, or is it something you have to download externally?
So Nmap is not usually downloaded default, usually on systems. On Kali, which is what we use and which we say you should install, it does come pre-installed with. Same with the other tools we'll look in a bit. So yeah, but it is pretty easily installable if you're using Debian-based systems. You could just do sudo apt install nmap. That goes with any distribution. If you're using, I don't know, Red Hat, maybe Arch Linux, nmap is pretty much on every distribution, so it should be pretty easy to get. But yeah, so as I said before, common security features for computers and servers is just to ignore these requests. So people aren't able to get a reply from your computer saying, hey, I'm here, I'm alive, you know, and then they usually will skip your computer if it's not up. Um, you can basically confuse your attacker into also not seeing any of the ports by just ignoring any uh, incomplete packets, because when we do port scanning, essentially we're trying to do a handshake with the server on that port using TCP or UDP. And if it's not able to do the handshake, then it considers that port closed. This is also how honeypots work, where you'll just have a service listen for any handshakes on this one random IP. And if it does, you're probably network scanning a bunch of different IPs, so you get in trouble. So there's a lot of different ways of how to defend systems against this stuff. So we looked at taking inventory of what's on the street. Now let's actually maybe do some version scanning. And it's pretty simple with Nmap. So version scanning is very simple. Let's start off with scanning the actual device it's on. This is pretty simple, right? We can just pass in Nmap with our target IP or target range dash capital O, and this will do operating system detection. And this does require sudo because I think it does some kind of handshake, which could maybe give away your IP to the machine you're attacking or scanning, rather. But you can see here that we see that, hey, this device that we previously scanned is running Linux. It even tells us some versions, maybe Linux 3.0, 4.0. You can see that, it detected some stuff. And this sometimes could be wrong, but most of the time it is correct. But you'll see any fragments that Nmap isn't sure about something in the logs. So dash O, very easy way just to do operating system detection. Here we have the next best thing, which is actually version scanning a port. So specifically, I talked about how you can scan all the ports. What if we only want to focus on that SSH port that was open? Well, we can specify it with dash P 22 for the port, and then we can use the flag dash S capital V for version scanning. And this will basically let us see what version. And here you can actually see that it found that the SSH running on that port was OpenSSH 7.4, Protocol 2.0. And this is kind of what fuels the entire reconnaissance workshop today. So, pretty simple way of just being able to do version scanning. So looking into OpenSSH 7.4, you can see that, oh my God, December 19th, 2016, and it even pops up with vulnerabilities as soon as we search it. So pretty old software. So 8 years old. When we search it, we have vulnerabilities show up instantly. So let's talk about how we can maybe now match vulnerabilities to versions, right? So we could actually go onto the National Vulnerability Database hosted by the government and search OpenSSH 7.4, and then you can see that there's 15 vulnerabilities matching that version. But that's really boring, so we're not going to do that. So we're going to find a better way to do that. So Nmap has this really cool tool or kind of script called Vulners, and this relies on NSCE, which is the Nmap scripting engine. Essentially, this is a scripting language made just for Nmap, where it will use vulners.com API. It's just a simple website that you give it some kind of regex or pattern to search, and it will find you all the CVEs in common with that version. And this will give you back a giant list. The requirements is that there's not really any other than needing the version. And as I said before, sometimes machines won't give you back a fingerprint for whatever is running, so you may not be able to get a version. But, it's a good way to just get a scratch of what's maybe available. So you can run this with sudo because it does require you to contact the API. So let's see how that looks. So here we can see we're running sudo nmap our target IP. And just at port 22, we're doing version scanning. So the script will actually know what version OpenSSH is running. And then we just pass in dash dash script vulners. And if you have Nmap installed, vulners, I believe, comes pre-installed by default. So you should be able to do this pretty much instantly as soon as you install. Here you can see what vulners found. For OpenSSH, we have a bunch of these vulnerabilities, which they even list. You get a UUID here, which is just a unique identifier. You have your CVSSS, which is the score of how bad is this. And then you have a link to the vulners link of where that exploit lives. So pretty simple. Um, Now, when we talk about the common vulnerability scoring system associated with CVEs, it's basically on a 0 to 10 scale. So 0 being from this could be bad, but you need physical access, you need to know the person's password. Essentially, you already know all the passwords for the system and you can log in. That's like a 0 level exploit, or being able to ping a device or not really, posing any security risk. And then 10.0 is basically like the, we're able to log in as admin on this one server by just sending a cat picture. And obviously, when we're doing reconnaissance or we're attacking or defending a system, we want to maybe focus on this range of vulnerabilities. And with vulners, it's really simple to do that. We can essentially just say, hey, pass in an argument to just filter out high scores. And we can really easily do that with just passing dash dash script dash args min CVSS equals 9. And this will basically just say, hey, give us a score of only 9 or higher. Um, and you can see that it did that. I don't know why. I think this is just some additional identifiers or something. I don't know why this is showing up, but as you can see, we mainly get those high rated vulnerabilities attached to that version. So here we can see that, hey, this system is already vulnerable. Uh, Pretty bad stuff. And this is essentially kind of all the levels of Nmap you're going to be using, right? We can figure out who's on the network, what services they have running, what versions, and if they have any vulnerabilities tied to them. So pretty cool. So let's talk about how this is useful. As attackers, I think it's pretty blunt. This is really useful because you know what machines are online, you know what they're running, and you know immediately, or not immediately, but at least you have a head start of, what software is being ran on the system and if it has any existing CVEs that you can maybe exploit. Looking at this from the defensive side, it's basically the same thing. Um, you as a defender should know what you're running on your network. And if something is out of the ordinary, such as, hey, I have a new device that connected to my network I don't recognize, you could run a Nmap scan and figure out that it's online or it's connected to your network, which, a lot of network management stuff doesn't actually tell you because you're using, consumer grade stuff. But if you just maybe run this occasionally once a week, you can maybe know if, I don't know, some government plant puts something in your house and is collecting all your data. Or you're maybe running a cyber competition or you're running some kind of infrastructure where SSH is supposed to be disabled on the machine, but when you ran Nmap on the device, it says that SSH has an open port and it's enabled. Or as we saw with the CVE scanning, maybe you can see if you have any outdated software. As I learned, our infrastructure has many outdated packages, so that kind of scared me. So there's many ways you can use this both for offensive and defensive use. It's pretty cool. So kind of like the TLDR, or kind of summary of Nmap is it's pretty simple. If you want to just look at no ports and just see if machines are up, you can give it a range and do dash SN just for simple host checking. If you want to scan all ports on a device, you just do dash P dash, and that will tell you all the 65,000 ports on there, if they're up or down, what they are, things like that. If you want to just select one port, you can specify that with dash P. If you want to check the operating system, you could do dash capital O. If you want to do version scan, you just do S capital V. If you want to do vuln scan, you just attach the script to a dash SV. And then if you want to do just only select the highest rated vulnerabilities, you can just attach that to the previous command and it will work fine. And, as a simple they realize that a lot of people are just combining a bunch of different things. They put all major four things in this one argument dash capital A, which I think does operating system discovery, version scanning, and then two other things I don't remember, but I think it does scan all ports on that one device. You probably don't want to do this on a large range because it will take you maybe minutes, maybe hours to run, but on a single device, it could take maybe seconds, maybe 30 seconds or whatever. So pretty cool stuff there. So I'm going to move on to actually pivoting from, knowing what vulnerabilities exist to actually finding the exploits. So here we're going to be mapping versions to exploits, which is a really fun thing to do. So as you may have seen before, when we ran our Nmap scan on that device or on that port, we saw that there's a bunch of exploit things, and this is what we want to see, right? So there's a lot of vulnerabilities out there, and we have a lot of POCs or proof of concepts slash exploits for those vulnerabilities, which will actually, give you the completed attack script or the methodology people used, things like that. So there's a lot of different sources for that. So you could look at the National Vulnerability Database or CVE database hosted by MITRE, or more commonly, you can use ExploitDB. This is actually what's packaged usually with Kali Linux when you install it. It's usually on your browser pins. It's on mine when I still have it installed, so you can see it up here. Um, my suggestion for this is don't be overwhelmed. Take it slow and only search one part at a time. So start with keywords that you know, version numbers. Otherwise, you're going to get bombarded with like 3,000 different exploits. You don't want that. And a big thing to note, just because it has a CVE or a vulnerability does not mean it has an exploit. So sometimes you will see stuff, but it may even say that it has an exploit, but it does not. So don't be surprised when you see that. So looking at ExploitDB. So as I said before, this is the preferred method for Kali users. And there's two different ways to browse it. There's the website database, which you can just go to exploitdb.com, which is in your browser if you just install Kali. Looks like this. You have a search bar. You have all the different things. Or, in my opinion, the better way is using SearchSploit. This is a command that's usually pre-installed on Kali if you download the Kali Everything meta package. And essentially, you give it keywords. You want things on OpenSSH 7.4. It will give you a list of exploits it has, the attack vector, and the exploit path, which is usually downloaded locally on your machine. So we can actually look at that by searching OpenSSH 7.4. And as you can see on the database on the website, we only get two results. But if you use that one tool SearchSploit, which basically does like a fancy grep of or search of the database, you can see that it finds more things. And that's because it also searches in ranges of things. So the 7.4 isn't in the title here, but because it's within this version, it will return that and it will give you some exploits. So pretty cool stuff. So I suggest using SearchSploit when you're looking at exploits. Plus, usually faster because it's already on your machine and you don't need internet access. So if I run SearchSploit OpenSSH 7.4, this is what I get. If I want to look more into it, for example, I want the second uh, entry right here, I can actually look at the path and I could do SearchSploit-P to look at the path of that one exploit. And you can see here that it even returns the entire thing. So if I actually run this right now and I do search exploit You can see it found it right here. Oh, it's the wrong one. Open SH 7.4. You can see found it right here. If I want to look at this one example, I'll do search exploit -p for the path. It'll give me a rundown of the path or the exploit name, the URL to the website, the path for the local remote exploit, because as I said before, this downloads locally, and every time you update Kali Linux, it will update your database, the CVE attached to that exploit, and the file type. So if I want to open this, I could just do something like less and open it in here. And now we can see that I'm in that full exploit for that OpenSSH thing. And I could just be able to run this instantly by running something like this. Oh, it failed. This is because it's using Python 2. So yeah, sometimes they're not updated, but you can easily convert them. So where we should be now is by now you should have been able to kind of understand how we can do some reconnaissance on a network. So figure out what's online, what they're running, and what versions and vulnerabilities systems contain. You should be able to map to an exploit using various different databases. If you're not able to find something with vulners specifically telling you, hey, this CVE exists on the system, you can maybe Google, hey, I'm running OpenSSH 7.4. What vulnerabilities or exploits exist? And you should be able to find some stuff. If not, you have search exploit, things like that. Um, and the hardest thing about all of this is not scanning that network or finding the vulnerability, but it's usually figuring out how to actually use that exploit. Most of the time, these are Python exploits, but some are just concepts, but they will still call it a exploit. That one last step cannot be trained, and this is kind of like the hard thing, right? As I looked before, this one exploit for this device or this version of OpenSSH is run in Python 2. So I might need to go in there, modify it so it can actually run on my system. Or if I have Python 2, I might be able to run it. Do I have Python 2? 2.7. Yeah, see, I might need to install more libraries, things like that. So it is a little of a uphill battle when you're doing this type of stuff. So don't expect it to be immediately easy. Sometimes it is, sometimes it's not, but be weary of that. And then kind of the last thing I want to cover is we kind of learn how to do a bunch of stuff with network mapping or Nmap and search exploit. There's another cool tool you can use, which is the Metasploit framework. So this is essentially the largest offensive security framework out there, developed by this cool company called Rapid7. To start, it should be pre-installed on Kali, but it's not initialized. What you want to do is you want to sudo msfdb, which is the database, init, so it actually makes that database. And then you can start opening it using MSF console, like this. And you'll get some cool ASCII art as always with these hacker tools, and it will give you a rundown of what's on here. But essentially, really cool hacker tool that we'll be using in the end. Within this tool, you have a lot of different things. You have, I think, 2,500 exploits, 1,500 different payloads. You have a ton of different reverse shells, bind shells, different things, shell interpreters for various systems and, outdated software, things like that, and a bunch of helper scripts. So if you're trying to attack a system, check if MSF console has it supported. Um, and if it does, you're going to have a really fun time attacking the system. It should be really simple. So with that said, we're gonna do a live demo, and I'm gonna use VirtualBox for this because VMware I'm not entirely sure of. So, as I said before, you should have maybe downloaded this OVA, 2.6 gigs. If you're not, try doing it now so you can maybe follow along. So I'm gonna open up VirtualBox. And VirtualBox is pretty cool because you can set up internal networks. If you go to this tools page or I don't know, somewhere file tools network manager, you're able to create a host only network like this. Say blah blah, whatever something's not allowed. You want to enable DHCP, so whatever machines you put on this network can actually get it. I'm just going to remove this. Oh, it does not like that. But I have one existing called VBox net 0, and this is my prefix. So this is my range that I'm scanning for. So what I'm going to now do is I'm going to go back out of this, and I'm going to import that OVA file that we downloaded from VulnHub. And it should be as easy as next, next, and then it's just importing that 2.6 gig file. Taking a while.
What does that? So if I haven't installed Kali yet, would you recommend I do a dual boot or would you recommend I get a virtual machine?
I do recommend doing a virtual machine if you're trying this stuff out, because you're able to take snapshots. So if you're attacking a system or trying to do like a hacking challenge and you break your system, you can just revert back. So when you're starting off with Linux, always start off with a VM. Otherwise, you can really easily break your system. Okay, so now it's imported. We have to do one little thing. If it's not done already for us, we have to go to the networking and we have to do host only adapter. So it goes on that network. And as I said before, VM box 0 is the one we want. Now, the premise of this website, this Vuln Hub thing, which is basically a collection of vulnerable machines, is that the machines exist, but you don't get the password. The way you get into the machine is you have to hack into it and basically be able to complete it by getting, root access or something like that. So what we're going to do is we're going to start this in headless. So we don't actually see any of the UI. Of course, you'll see it over here because it shows a preview. You can actually see that it's Ubuntu because of that purplish screen. Yep, you can see the logo. But now it's online. So it's on my computer, but I don't know where it is. So going back to orienting yourself, we want to figure out, I'm going to exit this real quick, figure this up. We want to figure out what the IP address of this machine is, right? VM or VirtualBox here doesn't tell us. So going back to the network, that one network I made has an IP prefix or its subnet range of 192.168.56.1 /24. So what I'm going to do is I'm going to do exactly what I said I was going to do before, and I'm just going to do nmap like this /24-SN, and this will scan all the IPs in that range without checking their ports, and this should tell us what's online. Now, this is usually the gateway in VirtualBox. This will be our host. And then we can see that, hey, we have another IP that's up, which is 192.168.56.102. And that's not something I've seen before. So what happens if I want to investigate this a bit further? So I want to go 102, and I want to just scan that one IP. As you can see, it returned it pretty quickly, but we have 3 ports open. We have FTP, or port 21. We have port 22, which is SSH, and then we have port 80, which is HTTP. Now this HTTP probably tells us there's a website. So what happens if we go to the website? I go back to Firefox, move this out of the way. All right. And I just go to this IP. We can see that, hey, this is the default page for the server. Web server is running, but no content has been added yet. So pretty cool stuff. So let's continue on with our journey of figuring out what this web server is running. So some kind of server on here. We need to figure out how we can do that. So the way we can do that, of course, is we could do -sv for version scanning. we'll enter that and let it run. And you can press any key as well to get a system update. But here we can see, hey, this is a Linux system as we saw before. Uh, we have an FTP server here running Pro FTPD 1.3.3 uh 1.3.3C. And then we have OpenSSH 7.2p2 running on Ubuntu. And then we have Apache HTTPD 2.4.18. So, now we know what's running on this. Maybe we can look at some of the more vulnerable things before. As I said before, we can maybe do some vulner scanning. So we can do -- script vulners and see if there's anything attached to any of those um, services. And this might take a little while because, oh, there we go. Only 7 seconds. Let me zoom out here. We can see there's a lot of different things. Web stuff over here, SSH, and then we have some 10. Oh, we have a lot of 10.0s for this FTPD. So this is maybe something you want to target. Now, we could actually click these to go to what's supposedly the exploit on vulners. And as we can see the actual problem of that vulnerability, but this is too boring. I just want to exploit stuff. So let's maybe look at search exploit. So as I said before, we can look for actual versions on search exploit by just tagging stuff. So maybe we'll just do copy this string over here and we'll do search exploit. And as you can see, we have two different exploits. And over here, hey, Metasploit. So there is a module on Metasploit, as we talked about. It's pretty cool. So let's look at Metasploit. It's really cool software. So to open up Metasploit, we're going to do MSF console to open up our console for Metasploit. And as you can see, we got different ASCII art this time. Pretty cool. We're going to wait for it to load. It has loaded. So now what we're going to do is we're going to search for that exploit again, right? Because I don't know the exact path within, Seach. I want search. I want to look up for that one exploit. So here you can see that it has found a matching module as we saw in search exploit. And you can see rank is excellent and it gives us command execution on that device. So why don't we use this? It even tells us how we can interact with this by getting more info on it or just do use 0. So here we loaded that exploit in. Now what we want to do with Metasploit is we want to configure where this is going to run on. Basically, what are we attacking with? Because we still need to give Metasploit an IP. So we can do that with show options, and this will list out the settings for this current attack. So here we can see for this one module, we have C host, C port, proxies, R host, R port. So we know FTP ran on port 21, so we don't need to change that. And we have the target host here, which ended with the IP of 192.168.56.102. And we can just do set our host to this IP. Oh, don't want to do the HTTP stuff. And we can do show options to see that again. And as you can see, now it's set to the vulnerable device. The next thing we want to do is we want to actually pick what payload we're going to be sending, right? This is a backdoor, so we want to use some kind of payload. And Metasploit has us covered with show payloads. This will give us the configurable payloads that Metasploit has. And I'm a big fan of the reverse shell because, I don't know, I like the telnet stuff. So we're going to do use payload, and then we can do payload cmd /unix/reverse. Press enter. Oh, use payload. There we go. Oh, no. Oh God. I think we have to go back here. Use 0. Show options. Okay. We have to show payloads. set payload. We want this one. Yeah, number 4. I don't believe you're allowed to just do set payload 4, so you do need to kind of type out the name. There we go. Payload is set. And if we do show options, we'll actually have more things. As you can see, now we have payload options. So we need to get our current IP address. And we can go back to here and we can do IPA. And as you can see on that VirtualBox net, our current IP address is 192.168.56.1. We're just going to copy this and do set lhost, which is the listening host or our current IP address that we wanted to bind back to. And this is everything we want. So show options to make sure everything is set. As you can see, we have the machine we're attacking on port 21, which is at FTP. Then we have the L host, which is the port we're on and how we want to connect back to. And then it will figure out all the other stuff and it will be automatic. And now for the magic, you just do exploit and send off that payload. And now Metasploit is handling this attack for us. So we can see we're sending the backdoor command. It's writing sockets. It's matching. And then A is input. So now we should be in. So if I run, command shell opened, we should be in. So let's run, who am I? And we are root. So we're in. Now, if I remember correctly, MSF console, if you're able to do shell and grab an actual shell, we can maybe get an actual shell session here. A proper one. There we go. And, who am I? We're root, ls. We can see all the files on the system. And when we're attacking Linux systems, we want to grab the passwords. And usually passwords are hashed, but we can break into those hashes, and those passwords are usually stored in etc/shadow. And as you can see, we have all the passwords for the machine that we just need to crack, and basically we're done for. So we fully pwned the system. It's that easy. So we're able to identify what this machine was running using Nmap. We were able to look for exploits, and then we're able to use an existing exploit pretty easily and get into the system. And now, we can do whatever we want in here. So if I want to run ls, look at, maybe ls/home. We have Marlin spike, so ls/Marlin spike. You can see all their personal files are here. Pretty cool. So it's that easy. So hopefully you learned something by, looking at how we can attack systems, and that is pretty much what cyber operations does, is we kind of go through the last step of attacking a system. And
yeah, here, for example, then if you have access to your shell and everything, can you copy files from their devices to yours, or simply just delete the entire running operating system?
yeah, we can do that pretty easily. We can essentially just SCP stuff over, or since it has FTP, we can technically FTP. We can even put our own backdoor on here and do whatever we want. But if I want to delete the entire operating system, I could just do so rm /. I think I need no preserve root, no preserve root, something like this. I think I need -r as well. So now this is deleting the entire operating system of that VM. So, it's not going to be able to delete the kernel, but hey, we're deleting the entire system on this one person's computer. So, we've gone through the entire thing. So, yeah, this is bad stuff, but it shows how much power you can get just by simply network mapping something and instantly go back to exploiting a system. Now, it's not always this easy, but a lot of systems, especially when you're looking at cyber competitions like CCDC and things like that, they're using really outdated software. And with outdated software, we usually have a lot of exploits being made. So sometimes it is pretty easy to get on systems.
And why did you choose to look at passwords, for example? What are those passwords
Um, just kind of like the flow of maybe not wanting to destroy a
Yeah.
system, but just get into it. Like if you're
But
looking
those, like, what were those passwords for instance? Because that's
like
exactly what
user
I'm saying.
accounts,
Okay.
right? Like if, you open up a computer, it asks for your username, that's what we're looking at is, figuring out what we can do there. And if we figure out that we can crack it locally on our machine, we can extract that hash, crack it, get the password, and then from there on, we can just log in as the user. We don't need to continue hacking them because that could arise suspicion. So, that is pretty much everything I wanted to cover for today's workshop. Hopefully, you learned something cool, especially with hacking machines and network scanning. But, go out there and hack the world to your desire. If you want to do more practice, there's a lot of different vulnerable machines on here. Some are harder, some are easier, but if you want to get more practice in, VulnHub, really good place to start. They no longer maintain it, which is a bit unfortunate, but a lot of machines are still up there. So if you want to get practice, you know, they're there. Yeah,
That's actually going to be in the Discord group chat.
it
You
will
guys see it,
be.
right?
Yes.